whey protein in there and stir it up. Blend some strawberries.
Okay, we're starting, so
chocolate.
all of your conversation is right here. Yes.
Hello, whoever is listening.
Okay, this is remove the bull. Sometimes expressions might appear equivalent, but they may not be exactly. How can you tell for sure? So we're going to look at y1 and y2, and we're going to see if they're equal or not. Okay, it says show that the two functions above are equivalent by factoring and simplifying y2. So let's write down y2, x over x squared plus 2x. What can we do with it?
Factor the x
From the denominator? Okay, so x parentheses, what would we have?
X times
x plus 2.
Good. Now what can we do?
Factor an x from the top.
Okay, so cancel? Okay, we got an x in the top and an x in the bottom, and that x is multiplying the x plus 2, so they're not married, so these can cancel.
So just be x plus 2.
What we have on the top?
1.
1 over x plus 2. Is that the same thing as y1?
Yes.
It is. So they look equal, don't they?
Yep.
Okay, what we're going to do now is plug these two into your calculator. We're going to plug y1 and y1, and y2 and y2. Okay, so how do you put 1 divided by x plus 2 in there?
1 divided by parentheses x plus 2.
All right. And then y2?
X divided by
X
x parentheses x squared.
plus 2x.
Good. Okay, and then we want to go to the table.
They're not the same.
So let's go to second table. And if you don't have this, you might be on auto instead of, or you might be on ask instead of auto, so you might need to change it back.
How do you change it back?
Go to second window,
Second.
table set, and put it on auto.
What if they're both on auto?
That's what you want.
There's a
You want them both on auto.
difference.
Okay, so at -2, are they the same?
No.
Yeah.
There's an error. What does that mean?
When does it say error?
It doesn't? What does it say?
Mine does.
That should be okay.
You got it?
There we go.
Okay. And then at -1, are they the same?
Yep.
And right, somebody said these are vertical asymptotes at -2 because there's an error. And then at 0, are they the same?
No.
No.
0.5 an error.
Okay, so y2 has an extra error, doesn't it? Okay, then how about at 3? I mean at 1, I'm sorry.
3.
So they're the same, and then 0.25. Okay. So the question is, why does y2 have an extra error? So in what way are the tables not equivalent? y2 has 2 errors, and y1 has 1 error. Or we could have put at x equals 0, y1 is 0.5, and y2 is an error. Okay, so let's sketch y2. So go back to y equals. We're going to clear y1 out so that we just have y2. Okay, and then we're going to do zoom 6. Now yours is gonna try to draw that asymptote, right?
It did.
It has a little line there. Okay, so where is the asymptote on this one?
-2.
-2. So let's draw a dotted line at -2. And then we'll sketch the graph. Okay, now remember this is y2, isn't it? And y2 is supposed to have how many errors? 2. So you would think it would have 2 what? Asymptotes, but does it?
Nope.
Nope. Just has 1. So this is a mystery here. How many vertical asymptotes does it have? 1. Does this match the information in the table above? No. The table says it should have 2, so we're going to find out why.
Well, couldn't it be the horizontal asymptote?
No, because the horizontal asymptote doesn't show up on the table.
Oh, okay.
Okay. Horizontal asymptote is where y is It's a little different. It's when x's get really large.
Okay.
Okay, now number 5, or actually this is supposed to be 4. I messed up. We're going to use this function up here above it. Find the vertical asymptotes of this function by setting the denominator equal to 0. So we're going to do 2x minus 6 equals 0.
What's that?
Okay, so 2x equals 6.
Divide by
X equals
2.
3. Good. So there should be what at x equals 3?
An error.
Okay, and let's see if there is. So we're going to plug in, we have to do parentheses around the numerator and the denominator. X squared minus 3x divided by 2x minus 6.
Yep, here's an error.
Go to the table. 0, 0, 1.5, 2, 1, 3, error. All right. 4, 2. Okay, so there is an error. So now what do we expect when we graph it?
An asymptote.
The vertical asymptote. Okay. Does the table support the location of the vertical asymptote found in number 4? Yes, the table says there's an error there. That's right. Okay, now we're going to sketch it. Okay, so we're going to go back to y equals. We have it in there, but we have to change the window. Okay, so we're going to go to window for x min, negative 9.4, x max, 9.4, y minimum, negative 6.2, and y maximum, 6.2. And then we graph it.
Slant.
Y equals X.
That's weird, isn't it?
Looks like linear.
Line here. Let me see what's wrong here. I think it's your window. I think it's that. Yeah, you didn't set your window. Did you set your window over here? Oh, you're still trying to do that? That one? Okay. Take the plot on. Is your plot on? That might be the problem. I bet that's it. I think it's that plot. Okay. Okay. What's weird about this graph? Several things.
It's linear.
It is linear. What else? You see
It's
something?
slant.
There's something in there.
There's a missing dot right there.
There is a missing dot where?
Oh, right there.
At 3.
At 3. Pretty interesting. Okay. Let's sketch it.
Spooky.
Show a little break there at 3.
Spooky like a mystery movie.
It is. It's like a mystery. But mine looks like a curve. Okay. What is strange about this graph? First of all, it's linear, which we did not expect. And it has a hole at x equals 3.
So it does have an asymptote still, doesn't it?
Well, it's not an asymptote, is it? It's just a little break. Okay.
But we knew there was going to be an error there.
Yeah, and there was, wasn't there? There's something there. Okay. So let's go back up here to this equation. Can we factor this?
Yeah.
Can you factor the numerator?
That's
And that would be
X minus
3. And then on the bottom,
2. 2, X minus 2.
okay.
And those two cancel.
What? Yeah, well, you know, the x minus 3's cancel, don't they?
Do 1.
And that's where the hole was. Okay.
Be
And what do you end up with?
X
X over 2, which is really 1
1
half x, which is this right here. With a line. See, these canceled out, and we were left with a line. And where they canceled out, we had a hole. Okay. That's what today is about. Okay. The question is, when you have an error, is it an asymptote or is it a hole? And we have to be able to tell. Okay. So usually values of x that make the denominator equal to 0 will create a vertical asymptote. That's what we've been doing this whole time, finding vertical asymptotes. Okay. Unless that value makes the numerator equal 0 also. Okay, notice, well, we'll look at when we see this one, what makes the numerator 0. Then this creates a removable discontinuity. New word, new term. Removable discontinuity. Get it? Removable. Removable. Ah, okay. Wyatt got it. All right. All right. A discontinuity is anything in the graph where there's a break. So an asymptote is a discontinuity. A hole is a discontinuity, but an asymptote is not a removable discontinuity. A hole is a removable discontinuity because they cancel out. Okay. That's what makes something a hole. We're going to look at this function. Okay, they factored the numerator and got x parentheses x minus 3. Factored the denominator and got x plus 1 times x minus 3. Okay, and then what happened to the x minus 3?
They canceled out.
They canceled, and that makes a hole. Okay, if they don't cancel, like the x plus 1 didn't cancel, that makes an asymptote. Okay, so the ones that do not cancel on the bottom are your vertical asymptotes. The ones that do cancel are your holes. So look at this one right here. They have a vertical asymptote at where? X equals negative 1. So right here. But because the x minus 3 is canceled out, there's a hole at 3.
Oh, so you can have both.
You can have both.
So if it'd be x plus 3, it'd be negative 3, a whole at a negative 3?
No, if this was, I mean, if both of them were x plus 3?
Yes, ma'am.
Yes.
Okay.
You would have a hole at negative 3. Okay. Yeah, now if this was x plus 3 and that was not, you'd
Then
have
it wouldn't
2
cancel.
vertical asymptotes. You wouldn't have any holes. Okay. All right, we're going to work on this. I do not like the way they say this right here, so we're going to mark that out. Okay. And notice the table had 2 errors, didn't it? One at negative 1 and an error at 3. But from the table, you can't tell whether it's an asymptote or not, or a hole. Okay, the only way you can tell is from the equation. All right, so now we're going to practice some of these. We're going to find the vertical asymptote, the removable discontinuity, which is really a hole, and we're also going to add to this the horizontal asymptote. Okay, so we're going to start by factoring everything. So factoring the top, we have x times x. What about 8
Plus 2 minus 3.
for 8?
It's 2
Plus
plus
4.
4.
Plus 2.
You're on the bottom, I
Oh, my
think.
bad.
You're on the bottom, yeah. Plus 2 plus 4. Okay, and then the bottom,
Minus 3 plus
good. Now we're looking for removable discontinuities. We're looking for things that would do what?
2. Make a whole cancel out.
Cancel out. Does something cancel out?
The
X plus 2.
Okay. So that is your removable discontinuity. We set it equal to 0.
Negative 2.
Right. So x equals negative 2. There's a hole at negative 2. Okay, then the vertical asymptote would be the one that did not cancel out.
X plus 4 over x minus 3.
No, just
Oh,
no,
on the
just the
bottom.
bottom.
My bad.
Right.
X plus 3.
And you don't have to show setting it equal to 0. I'm just doing it this first time. Just show you where they came from. Now, does anybody remember yesterday we learned about horizontal asymptotes? How do you tell? What do? You compare something.
It's at 1.
It is at 1. Why?
Because
The degree of the exponent.
The degree of the exponents are the same
So
we look at
divide
the
the
num-
top coefficient by
by
the
the
bottom.
bottom coefficient. Very good. So 1 divided by 1 is 1.
If the bottom is bigger, it's
The degree of the
0.
bottom is bigger, it's y equals 0. Good.
And if the numerator is
It's
bigger,
larger, it's
the n equals none.
none. Very good. You do remember. Okay. Okay, then let's skip to 3. I'll let y'all do 2 here in a second. Let's skip to 3. How would you factor that numerator?
Take a 2 out.
Okay. Be 2 parentheses.
X minus 5.
And over x minus 5 x plus 1.
Good.
And x minus 5 cancel, so your RD is at 5.
X equals 5. Good. And then what about your vertical asymptote?
It'll be negative 1
X equals negative 1. And then the horizontal asymptote.
is 0.
Y equals 0. Very good. Why is it 0?
Because the bottom's larger.
Right, the exponent on the bottom is larger than the exponent on the top. Okay, so when that is the case, then the horizontal asymptote is 0. Okay, that was the part that you missed, Ryan. The horizontal asymptotes. Uh-oh, it went blank. When did it go blank?